Hello and welcome to the Daily Space. I'm your host, Dr. Pamela Gay, and I am here to put science in your brains. Today, well, after the insanity of last Thursday and Friday, we find ourselves kind of short on news. It looks like, well, everyone slept in and kept their science to themselves on this particular Monday. So I decided I'd take this opportunity to talk about the science that all of you are helping us to do. So the image that you see over here, this is an image of the asteroid Bennu. And that's an okay image of it, but let's zoom in a little bit so that you can appreciate it in its full rocky, well, I'm not sure glory is the right word. Terror? Can we go with terror? This particular object is an asteroid unlike anything we expected. It is rocks, on boulders, with more rocks all the way down. And in looking at it, you're seeing and bringing to our attention some really cool different features on this world. Now, this particular image that we're looking at is one I just randomly pulled out of the database. It is literally just image 4300. It seemed like a good number, so I grabbed it. So this is image 4300. And like so many images, it has random shiny things that we don't really know what are yet, but the science team knows that they're there, and they're working on studying them. It doesn't seem to have any of the cool sedimentary features that some of you have found in other images, bands that appear to go across the rocks showing different layerings within the stones, something we totally didn't expect to find, but which you guys have found in these images. You can see just how different these rocks are one from the other. This is a single image. These all have the exact same lighting conditions. If they were all the exact same kind of rocks, you'd expect them to all pretty much look the same, but they don't. You see these dark rocks. You see these oddly shiny rocks. You see rocks that even have shinier spots on top of the shinier rocks. This world is cool. It's awesome. And you guys are part of us doing science. Now, one of the reasons that I was pulling this particular image out of the database was to do a little bit of, well, data check. And just to warn you, there is a thunderstorm going on here, so if I have any dropped frames or you hear any weird noises or see odd lighting, it's because there's a Midwestern thunderstorm. Carrying on. The reason I pulled this particular image out is I wanted to take a look at the data. I know different people are contributing in different ways, and that actually gets reflected when I look at your data. Each of the bigger images, and this is one of the bigger images, gets broken up into 9 overlapping pieces. And you can start to see those overlapping pieces in this image. Each of those 9 separate images gets handed out to 15 different people. Each has their own, well, point at which they say, enough is enough. I can't mark another rock. Each of which, well, focuses on different things and has their own failure modes. Looking at this random image, you can see that some people mark rocks a lot more than others. In this band to the left, if you look at that, it's actually a whole bunch of little blue dots that are just slightly offset from each other because everyone was marking the same rocks, but not with the same centers. And looking at only the boulders, what we're really enjoying is we can get a sense of the shape of the boulders based on how many lines line up and how many don't. Rocks that are more circular have an array of lines that go round and round. Rocks that are long and narrow have a whole bunch of lines side by side. And this is extra information that helps us get extra science out of what you're doing. Now, for those of you who haven't yet participated in Bennu Mappers, I just want to bring up the site so you can see what you're missing. Go do Bennu Mappers. You should all be doing Bennu Mappers. Grumph. Okay, so this is our website. It's part of CosmoQuest, just like the show is part of CosmoQuest. We have as a goal for our project to treat you as much as we can like, well, I would treat my students. This means I'm here to mentor you, but not always, because sometimes I'm on airplanes traveling. It means we're here to teach you. This is all the streams that we do, all the podcasts that we do. And we're here to work together. This is when Annie, mostly Annie, and sometimes me, does the Bennu Mapping support streams where we can all sit together and support each other as we go through and do this often tedious science. And the truth is, a lot of science, the doing of the science part is kind of tedious. This is the thing they don't tell you in the news articles. They make it all sound exciting and awesome, and the reality is, science is a whole lot of staring at your computer trying to figure out what's wrong with the software you wrote. A whole lot of staring at your computer trying to figure out why the image that you processed does not look like what you expected it to look like. It's a whole lot of just staring at things, trying to figure out what it is that you're looking at, until one day everything clicks into place and you have a science result. So I'm going to go ahead and I'm going to just launch the application so that you can see the tutorial. Now, I should be able to embiggen this. I may need to move it around a little bit. I think this is as big as I can get without things trying to escape off the side of my screen. Now, the reason that I'm starting with the tutorial is I want to give you a sense of what we thought Bennu would look like. Because, oh wow, were we wrong. We had to write the software to map Bennu before the spacecraft even got there, because we needed time to test it and make sure that every aspect of the data reduction process worked and would deliver the data to the mission team that they needed. This means that we fed into the initial system on a private server data that some of you helped us mark out as we tested it initially using people from the Weekly Space Hangout crew. Thank you, Weekly Space Hangout crew. After that, we got together and, well, Danny and Karina at the OSIRIS-REx mission got students and people attending seminars to go through and make marks. Got their colleagues to go through and make marks. And at this time when we were testing everything, we were using data that the Hayabusa 1 mission, just Hayabusa is what they called it back then, that the Hayabusa mission took of the asteroid Itokawa. This little rock we thought we were wrong, we thought might be similar to Bennu. And so those are the images that you see in this tutorial. These are Itokawa. Right now it's walking me through the process of deleting any mistakes I make. It's always good to learn how to erase before you start, because mistakes get made. Next, it's going to walk me through how to mark craters, because we thought there would be these nice crisp craters. These examples on the right, these are what craters actually look like on Bennu, and I don't know about you, but it's really hard to see that there's craters. We thought the craters would look like the one that the tutorial is about to mark for us as an example. We thought they'd be crisp, they'd be pristine, they'd be easy to mark. We were wrong. We were so wrong. So I see Larry asking in the chat, is there going to be a daily space summer hiatus or reduced schedule? We will be taking the week of 4th of July off, but we're going to be here all summer, helping you out, helping you science. There may be another week taken off later in the summer, but we're not going to go on the 12-week hiatus that most of the podcasts and YouTube streams are going on. Okay, so sometimes you need to hide your marks so that you can see what rocks and stuff you missed. show your marks. It's just walking us through all the tools. And so the next thing it's going to show us how to mark are the boulders. These boulders in this image, well, this is what we thought the boulders on Bennu would look like. We thought they'd be mostly tiny, easy to see, not that many of them. But the examples on the right show you what the actual boulders on Bennu look like. This is a lesson in not every asteroid is the same. And we knew this. Ceres and Vesta are radically different worlds, but they're really worlds, dwarf planets, things that are differentiated, have undergone geologic processes. Itokawa, Bennu, Ida, a lot of these asteroids, they're just lumps, kind of peanut-shaped or dog biscuit-shaped, orbiting the sun. Yeah, we thought, yeah, they vary, but how much? Well, we were wrong. We were wrong. And it wasn't just us. The Hayabusa 2 mission is having the same issues. And rocks. We knew there would be a lot of rocks. The dogs are now barking at thunder. I apologize. Apparently the thunder is deeply offensive to the doggos. And YouTube people, I saw your complaints that there was too much dog involved in these episodes, and we're going to work to get the ratio just right for you. So right now the software is going through, and it's marking a couple of rocks as examples. And here I'm going to zoom in even more so that you can see. Those are the rocks. Those are the rocks that it's marking. And at this point, it's going to ask me to go ahead. One moment. I'm so sorry. Dogs. My software appears to have given up on me and is not doing what I thought. One moment while I reset the software. I think everything has opinions today. It does not want to bring up the background again. Hold on. Okay, I think we have everything back. So what I was going to show you is there's a whole lot of rocks in these images, a whole lot of rocks, many rocks, lots of rocks, in fact, hundreds, maybe thousands of rocks. Yeah, there's rocks. And currently the tutorial wants me to mark 80 of them. Now, I don't want to mark 80 of them in the tutorial because that's a lot of effort. But the reason that we have you do so many in the tutorial is to give you a sense of just how hard this project is. And it's not hard in the sense of difficult. It's hard in the sense of, oh my God, how are there so many rocks and how do I mark all the rocks, all of them? And a lot of people have asked me, do I have to mark every single rock? Well, no. This is that image that I showed you earlier of the results. And you can see different people mark different numbers of rocks. In general, the rule of thumb is if you can mark everything that is half a blue dot in size up to 3 blue dots in size, well, that's what we need. It's possible to mark dust. Don't do that. You'll never finish an image. It's possible to mark tiny bits of gravel. Also, don't do that. You will finish the image, but it's going to take an awful long time and doesn't really add a lot of the information that we need. So stick to marking things that are half a blue dot to 3 blue dots in size. Now, above that 3 blue dot limit, that's when something is considered a boulder. So you can see in here, this boulder, I am having trouble. I can't show you my cursor is what I'm learning. Let me just zoom in. So you can see this particular rock here, both boulders, in fact, in this image, all 3 boulders in this image, they're right at that limit of, is it a boulder, is it a rock? And different people had different opinions, and that's fine. The boulder measurements here were the correct choice. So try and mark boulders as boulders. Try and mark things that are 3 blue dots and smaller as rocks. And together we're going to be able to get through all of this. So yeah, it's a whole lot of data. But the cool thing about it is you can see, looking at this, I'm going to zoom in more again. I'm going to try and zoom in more again. People are accurately figuring out where the boulders are, where the rocks are. Here there are some boulders that got ignored by everybody. I can see exhaustion setting in. But when I turn the rocks on, it turns out people are at least marking things as rocks. So everything is getting marked. You guys are doing it. You guys are doing the science that the OSIRIS-REx spacecraft needs you to do. Now, I was just saying, I'm not going to mark 80 rocks in the tutorial. What I'm going to do instead, this isn't me. I'm going to open a window that is me, because that was the CosmoQuest window. Sorry about that. I'm going to open a window that is me, if I can, on this computer. No, I'm just going to apparently register for a new account. My password is in a password manager that is not on my streaming computer. So let me show you just how easy it is to register. I'm going to register as Star-Lord. I'm going to give Star-Lord the email address, basically my email address. So PLG. Now, if you add a plus sign to your email address, the plus sign stuff gets ignored by your email browser, which allows me to register a whole bunch of email addresses all to the same actual email address. Star-Lord's first name, I don't remember what his actual name is, because I am apparently a Guardian of the Galaxy's poser instead of an actual Guardians of the Galaxy fan. I'm just going to type in something. Okay, and now I'm registered, except I didn't type the passwords the same. There we go. So now I have an account. I'm going to go ahead and save it so I can use it later. And I can launch the application. Purple Star-Lord. Peter Quinn, that's right. I do like purple Star-Lord, though. I do like purple Star-Lord. I don't want to take this. So if you really don't want to take, you can just click skip. I'm done now. It's gone. I'm fine. I'm looking at rocks. And that's all it takes. And now I can mark things. And one of the super cool things that I'm seeing in this image is, and here I'm going to zoom in again, there is this faint linear feature. Maybe it's not real. Maybe I'm just making stuff up in my brain. But I can pretend. Let me see if I can move this higher. I am seeing a linear feature starting at the bottom of your screen. Just this little sticky uppy bit. And linear things are just cool. They're just cool. And I love how these rocks have so many different facets, and you can see the shiny stuff. Now, when you're marking, don't zoom in like that. I was doing that to allow you to see things better. Instead, just do it like this. Just do it on the regular zoom. Sorry that I have to keep moving things around. Do it on the regular zoom. And that's what the science team is using. And if you zoom in, there's going to again be the temptation to mark too many rocks. Do not do that. This zoom will prevent you from marking too many rocks. Okay, so that's what I wanted to do today, because slow news day. But that doesn't mean this is all you get. You might have noticed I really didn't leave time for questions. I didn't ask for questions. This is because we're about to be joined by two guests. Two of my colleagues, Georgina and Jordan from the Planetary Science Institute, are going to be joining me via Zoom in just a moment to help you understand some of last week's cooler news stories. They're totally in the land of planetary, and since I'm an astronomer, I thought I'd bring in the experts. So before I click over to allow them to join via dogs, there's going to be a dog bit for a moment. Assuming there's dogs up here. There are not dogs up here. You're going to look at an empty dog bed. No, you're going to look at the standby video for a few moments. While the standby video is playing, I'm going to bring them in via Zoom. Before I do that, I would like to remind you that, well, this is a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are here thanks to you. We are here thanks to the generous financial We are here thanks to the generous financial contributions of people like you who donate via Patreon, via their subs, via their bits, and via, well, CosmoQuest.org/x/donate. There's a lot of ways to give, and not all of them are financial. If, like me, you find you just don't have extra money to give to all the things that you value, well, one of the things that we value is when you do science. And when you share everything that's going on here on your social media feeds and invite your friends, family, enemies, we don't care. We want everyone just helping the world make a science. So spread the word and stay here, because we will be right back in just a few minutes with special guests to talk about that mysterious object that, well, might be the remnants of an impacting asteroid on the south pole of the moon and, well, what formed the north pole of Vesta. Stay tuned. We will be right back in a moment.